In this video, we'll be going over notes for 5.4 Part 2, Graphing Rational Functions. In this note packet, in this video, we'll be putting together everything we've learned about graphing rational functions so far. So below the bell ringer, we have an overview of what putting all the pieces together will look like. When we graph rational functions, there are two things we need to remember. One, rational functions are functions. They must pass the vertical line test. That means if you have a function that looks like this, it's not a function, right? If I put a vertical line through here, this would cross the vertical line twice and therefore is not a function. So you always want to check your graphs when you're done to make sure that you haven't created something that isn't a function. The second thing you want to keep in mind is that graphs have to hug asymptotes. So if you have a vertical asymptote like this and a horizontal asymptote like this, your graph should move along the asymptotes. So I'm hugging the horizontal asymptote here and then the vertical one, and then maybe I'm hugging the vertical one here and then the horizontal one along here. You want to be going along the asymptotes. Alright, so let's think about all the things we've learned how to do so far. We've learned how to find the horizontal asymptote. That's usually the first thing we want to look for because it doesn't require that we factor at all. Instead, we can just start drawing a horizontal line. Then we'll factor and simplify the function. When we factored and simplified, that allows us to identify holes and asymptotes. If you weren't in class, go back to the video on holes and asymptotes so you know how to do that before you attempt the problems in this packet. Then we'll find x and y intercepts, and then we will be ready to plot them on the graph, so actually graph them, and then we'll be able to actually make some deductions about where our graph will be. And then if absolutely necessary, we'll actually plug in some points to plot. So let's go to the next page and actually put this information to work. My first example here I realize is actually the most complicated, so we're going to come back to it, especially since we're doing this on video and not in class. We'll come back to it at the end. We're going to move on to example 2. So here in example 2, the features of the graph, so when we've identified the horizontal asymptote, the vertical asymptote, the holes, intercepts, etc., we'll be able to figure out what the graph should look like without testing any points. You'll see how this is going to work. Let's start with the horizontal asymptote. For the horizontal asymptote, we need to look at the degree in the numerator and the denominator. The numerator is degree 1, as is the denominator. That means this is a balanced equation. So my horizontal asymptote is y equals whatever the coefficients are. In the numerator, the coefficient is 1. In the denominator, the coefficient is 1. So it's 1 over 1, which is just 1. Y equals 1. Alright, vertical asymptotes. For the vertical asymptote, we look at the denominator. We set the denominator equal to 0. If x plus 3 is equal to 0, then x equals negative 3. That's where our vertical asymptote will be. Okay, so let's actually plot that. We've got a horizontal asymptote of y equals 1. We have a vertical asymptote at x equals negative 3. Okay, are there any holes? Well, there aren't any factors that cancel out in our function, so there are no holes. I'm going to write NA. X-intercepts. Remember to find the x-intercept, we set y equal to 0. So in this case, we have 0 equals x over x plus 3. Multiply both sides by x plus 3. And multiply it over here. These cancel. We end up with just 0 on the left side because anything times 0 is 0. So we're left with x equals 0. So we have an x-intercept at 0, 0 at the origin. That's my x-intercept. Okay, for the y-intercept, we set x equal to 0. When we do that, we get f of 0 equals 0 over 0 plus 3. 0 over 3 equals 0. So our y-intercept is actually our x-intercept as well. It's the origin. Okay, we are ready to start graphing. Our graph is split into two main sections by the vertical asymptote, the left side and the right side. On the right side, we have one point already plotted, and that's our xy intercept, the point at the origin. Our graph has to go through it, and it has to hug the asymptotes. So I'm going to start at it, and then I'm going to approach my vertical asymptote, and then I'm going to move over towards my horizontal asymptote. So I've hugged the horizontal asymptote, gone through the origin, our intercept, and then gone down towards our vertical asymptote. If we hadn't plotted it there, if we had instead put it up above, we would have created a y-intercept here at maybe 2 that doesn't actually exist. And we wouldn't have gone through the true y-intercept at the origin. That's how we can know that we shouldn't plot above the horizontal asymptote. Okay, let's check out the left-hand side. On the left-hand side, if I wanted to graph my function down here, like this, hugging the asymptotes, I would create a new x-intercept. I would have to cross the x-axis. But we don't have an x-intercept at -6. So this part can't be correct. We can't cross the x-axis because there's no x-intercept there in this left-hand section. So instead, I have to be in this upper left quadrant. There we go. That is our finished graph. Although this doesn't quite meet the function test, it needs to not go through the vertical line. All right, that's better. That is x over x plus 3. Now, in this case, you can actually think back to our parent function. This is pretty similar to 1 over x plus 3, right? We have the vertical asymptote at x equals -3, and that's the key feature. We've met that requirement here. So that's just connecting it back to a previous lesson. All right, I'm going to end this video, and then in our next video, we'll talk about example 3.